Today, we're going to look into first law that's particularly applied for rigid tank. And this is one of the very important concepts in thermodynamics. Let's do a quick review on first law. If you haven't done the videos on that or you need to refresh, please go back to look at that first law of thermodynamics. Then we're talking about there is delta E equal to Q minus W. Delta E is the energy of the system change, and Q is heat, W is work, right? And also we made assumption if delta KE and delta PE both are equal to 0, if they were stationary, there's no kinetic or potential energy change. So this change of the energy inside the system will be just delta U. That's going to be equal to Q minus W. So we have this formula, and there's a sign convention. So review the sign convention on them. It is if the Q will be positive if there's heat coming, right? And it will be negative if it's heat leaking out of the system. And in terms of work, if it's work done by the system, that's going to be positive. And if it's work done to the system, that's going to be negative. So those are the sign convention we had talked about before. Now let's look into a little bit deeper. So we have delta U equal to Q minus W. Now this work, if we're going to classify this work with two types of work, the first one is going to be the boundary work, right? It's the work done by the boundary. Another type of work, we're going to just others. And often in thermodynamics, other type of work you see in a closed system would be like, for example, you have an electrical system and have a resistance that's trying to heat it up. The substance inside the system, that's going to be other type of work. So those are those two different ones. Now, knowing that, we're going to look at a special situation, which is our rigid tank. If it's rigid tank, we learned before the boundary work is equal to 0. Right, there's no boundary move up and down. It's rigid work, and you can look at that video on boundary work. So then if that's a situation, this is going to be equal to 0, then our delta U internal energy change will be just equal to Q minus other type of work. And if we were trying to move Q to be one side, then our heat transfer Q will be just going to be equal to delta U plus others. Okay, so that is equation. And if other type of work is 0, there's no other type of work, then we have the heat transfer Q here will be just equal to delta U. So those two equations are very important for rigid tank. And will this apply for every single system, regardless ideal gas or non-ideal gas, or we call real substance? Yes. Why? Because this is first law of thermodynamics. It applies for everything. And the only condition we have here is what? It is rigid tank. That's all. If it's a rigid tank, we are going to use those two formula, and it's very important. Heat transfer is equal to internal energy change delta U plus work others. If there's no other work, heat transfer just gonna be governed by the internal energy change. That's all. All right, I'll see you next time. Bye.